Okay, what, what is a series? A series is basically a sum of a sequence. Okay, the notation. We're going to look at either sigma, since we are dealing only with infinite series, infinite sequence and infinite series, we're going to go n equals 1 to infinity of a sub n, or because we know that we are dealing with infinite series, we just write sigma of a sub n. Now, for those of you who have deficiencies in sigma notation and stuff like that, I have a handout for you. This is really a handout from pre-calculus. Go ahead, pass it around. Let me briefly show you the handout, but only briefly because you're going to have it. This tells you about sigma notation. This has to do with sum of a finite sum. So when we go from, let's say, 1 to n, of course we go from 1 to infinity, so we need to take the limit as n goes to infinity when we're dealing with this. Okay, so let me put it aside and continue. And let me just give you two examples of finite sums. So here's an example, 1 or A. Let's look at the sum 1 plus 2 plus 3 plus dot 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 plus n, the general term. Okay? Do you know what is the sum? This is Gauss' formula. Gauss said, you know what's this? This would be, there are n terms in this series, right? You take the average. The average is 1, the first plus the last divided by 2. So the average is 1 plus n divided by 2. And since we have n of those, it will be n times this thing. Okay. So this is the term, the general term for the sum of this series. What is the sequence? Well, this is arithmetic. Okay, what about if you have something else? If you have b equals 1/2 plus 1/4 plus 1/8 plus 1/16 plus dot dot dot, and the general term will be 1 over 2 to the power of n. Well, you may not know it, but the result will be 1 minus 1 over 2 to the power of n, like so. I think it's plus. I need to check on this one. Okay? So, if we take the limit now for infinite, this is for finite, so the infinite series R, okay, for A, we're going to take the limit as n goes to infinity of what we see here, n times 1 plus n divided by 2. Well, this will go to infinity. So this is going to converge. So there's nothing to do here. But if we do part B, if you look at the limit as n goes to infinity of 1 plus 1 over 2 to the power of n, like so, well, 2 to the power of n will go to infinity, and 1 over 2 to the power of n will go to 0. So this will be 1 by itself. Okay? And Tommy, you need to go. There is one more thing that I want to show you. It's a geometric series, but I guess time is out, so I'll have to show you this on Thursday. Okay? Unfortunately, let me just put it on the paper so you can look at it. You're going to need it for the homework for section 11.2. Look at the result, guys, before you leave. Just look at the bottom part. Okay? If you have a geometric series, yo, Tommy, listen. I know work is waiting for you. I'll show you how to get to it, but this is the result. Okay? If the geometric series, remember we talked about R. Now if that ratio R is less than 1 or greater than negative 1, the absolute value is less than 1, then the sum, the series becomes the first term divided by 1 minus R. This is something you need to know in order to do the homework from 11.2. Okay? So either write this formula or I'll put it on, I'll add this information, write it down in your notes, and I'll have it available to you on WebAssign. Okay? That's it, folks.